Hello everyone, welcome to the course on computer aided drug design. We will continue on the topic of quantum mechanics. I did introduce two different quantum mechanics method. One is called the ab initio method, other is called the semi empirical method. The ab initio method is detailed calculations, very accurate, so it is limited to tens of atoms only. Okay. So, you need a very good computational resource. It can be applied to organics, organometallics, molecular fragments and so on, enzymes and so on. It can be done in vacuum or implicit solvent. Okay. We can look at ground state, transition state, excited states. Okay. Some of these softwares like GameS, Gaussian, they all work on ab initio. So, it is not really useful for computer aided drug design. Semi empirical methods are that way much more relevant for us. We can go quite a lot, hundreds of atoms unlike tens of atoms. Okay. This can be applied to organics, organometallics, small oligomers, peptides, nucleotides, saccharides. We can look at again ground transition, excited states, but little bit approximate. So, there are many methods AMPAC, Mopac, Zindo and so on. Of course, the other one molecular mechanics, which we spent a lot of time in the previous classes, is good for thousands of atoms, and generally we use that for docking purposes. So, for limited active site, maybe you can go into this side of semi empirical methods, okay, whereas rest of the protein you use molecular mechanics methods. So, nowadays a combination of semi empirical methods and QM methods are coming into MMQM. So, predominantly you use MM method and only the active site you use QM method. So, so that your computational effort is not too much. So, we looked at some approximations. One, the most important is the Born-Oppenheimer approximation. What it does is it reduces the degrees of freedom between decouples the electron and nuclear degrees of freedom. So, they assume this approximation assumes that the nucleus is fixed. So, we have only degrees of freedom for the electrons. Okay. Then came the Hartree-Fock. This is a very important one as well. So, the main electron problem is approximated by a sequential calculation. So, you take the ith electron and you take the average potential of rest of the electrons and then see the interaction. Okay. So, it becomes one electron operator. Then you take the next electron, then take the average of rest of the electrons and then see the interaction. So, you do not look at all the electrons which may be if you look at each electron interacting with the remaining electron, you are going to have huge number of calculations, whereas by doing this you reduce the calculations tremendously. But still ab initio methods take more time. So, semi empirical methods take care of many of these calculations using certain fitted equations and parameters. Some of the major methods in ab initio, GameS and Gaussian. Semi empirical method. So, parameterize the Hamiltonian by fitting it to experimental data or results from ab initio. So, these calculations in semi empirical are much less demanding, unlike ab initio. They cannot be applied to systems which are radically different from those used in the parameterization. It can be used for heat of formation, looking at ionization potential, optical spectra, electrostatic. So, we can simulate some of the spectroscopic behavior of molecules and so on. So, the molecular orbital methods, most of the semi empirical methods are based on molecular orbital. So, it approximates neglect of 3 and 4 center integrals in the j k terms of the Hartree-Fock equation. Okay. So, some methods give certain parameters or certain equations to consider these 3 and 4. Okay. So, for molecules with a large number of electrons, evaluating of these integrals can be very computationally challenging. Experimentally determined parameters or sometimes from the ab initio for compensate the missing integrals 3 and 4. Okay. So, it can be obtained from measured or calculated from ionization potentials, electron affinities, spectroscopy and so on. So, some of these methods, large number of methods are there for semi empirical methods. Okay. CNDO, CNDO1, CNDO2, CNDOS, then intermediate neglect of differential overlap, INDO. We looked at some of those definitions yesterday. Then MINDO, that is modified INDO. Then we have the AMPAC, then we have the INDO ZINDO, then modified neglect of diatomic overlap, MNDO. Mopac is there, Mopac takes care of that. Then we have AM1, Austin model 1, then parametric model PM3, then SAM1, and PM3 has become even PM6. So, large number of semi empirical methods. Generally Mopac is a good program, and we can use these methods which are really good for your calculations. So, what it does is it ignores core electrons, semi empirical method. So, it takes only core electrons, reduce nuclear charge, introduction of function to model combined repulsion due to nucleus and core electrons. So, you have function which take care of that rather than using integrals. Okay, this is taken from this reference. Minimum basis set of functions to account for valence electrons. Okay. So, we have a basis set, we defined what is the minimum basis set. So, we take that to model the valence electrons, that is electrons in the outermost orbit. So, what are the limitations? We can do thousands of atoms due to diagonalization of Fock matrix. Calculations are extremely close but not exact. It cannot predict for unknown compounds. So, you need to keep that in mind. It cannot predict for unknown molecules and unknown compounds. So, sometimes you cannot trust the calculations because there are a lot of parameterization and equation fitting. But once the atom has been parameterized, all possible compounds can be calculated. So, that is the advantage, and for especially for drug discovery we are talking about carbon, nitrogen, oxygen, sulfur, maybe chlorine. So, there is no problem at all. Okay. Mostly for drug discovery semi empirical methods can be used without any problem. So, it can look at bond breaking and forming reactions, that is very important. Suppose I am making a prodrug. As you know, prodrugs are not really drug, but molecules which go inside the body and they get broken because of action of some enzymes, and then the active ingredient comes in. So, we can look at bond breaking energies for that, bond forming reactions also we can look at, whereas molecular mechanics methods cannot be used for that. That is the main advantage of semi empirical quantum mechanics method. We can look at electronic wave functions also. Okay, that is another advantage of that. So, we can look at energies of various orbitals, we can calculate them, that is another advantage. So, what is the energy difference if you want to move an electron from one orbital to one unoccupied orbital. So, we can do that sort of calculations. And of course, it saves a lot of time for calculations, although it is quantum mechanics, it is much faster. So, we get a lot of information, but with less amount of time. So, that is the advantage of using semi empirical methods. Okay. So, semi empirical methods relatively reliable, time efficient calculations of chemical systems via minimal basis set. So, that is the main advantage of a semi empirical method. It is relatively reliable, time efficient calculations, chemical systems. So, we can look at bond breaking, bond forming, moving activated state, ground state of molecules. So, we can look at all these energy values using this semi electronic energy, nucleus energy. So, we can calculate all that using semi empirical method. So, some good methods like I mentioned, neglect of differential orbitals, okay, AM1, PM3, they are all very good methods actually. Okay, so, these are all really good methods. Okay, let us look at one of those website where there are a lot of methods are given in this website. Okay, so you see list of quantum chemistry and solid state physics softwares, huge number of softwares are given. So, this is a very nice resource for you guys. So, have a look at it. License, academic license, generally we get it free, commercial means you may have to pay. So, these are the various packages. So, we can look at what these methods are by clicking on that. So, you can see so many different Mopac, academic, commercial is also there, academic is also there. So, if you show that you are academic, they give you a license key. Okay. So, large number of methods, you can see this. Okay. So many different methods. The language, they have used Fortran 1995. Okay. Basis set, what is the basis set they have used? Okay. Molecular mechanics calculation, some of them do molecular mechanics, as you can see SSS, some of them cannot do, semi empirical calculation, some of them can do, some of them cannot do. Okay. Hartree-Fock calculation, some of them can do, some of them cannot do. Density function method, some of them can do. Okay. So on. So, large number of methods we can use. As you can see, some of them are academic. So, it is free, academic, free. Okay. Some of these are downloadable, executable, some of them needs to be compiled. So, if you need to compile them, obviously you may require certain library functions and all those things actually. So, if you get help from some IT person, it is easy for you to compile them. So, you can see free, academic, academic means you get academic license claiming that you are a student or a faculty, free GPL. So, we can see free of them. Okay. Quite a lot of these methods. So, look at this Columbus for example, if you click on that Columbus, the computational chemistry software suite for calculating ab initio molecular electronic structures designed as a collection of individual. Okay. It has got of course ab initio, so it has got a Hartree-Fock, self consistent field and so on. So, let us look at something which has got semi empirical also. AMPAC is there, this is an academic. So, AMPAC is a general purpose semi empirical marketed by Semi-Increment and was developed originally by Michael Diver. So, some methods are now a graphical user interface, whereas the older methods will not have graphical user interface. Okay. So, look at some other semi empirical method, DFT is there, Dirac, DMOL 3, these are all commercial methods. Mopac is academic, so that means you have to show that you are an academic, and then it also has the semi empirical. Okay. So, we can go to Mopac. Okay, this is a very popular, Mopac is a very popular computer program used in computational chemistry, semi empirical quantum chemistry. Mopac has several things, PM7, PM6, PM3, AM1, MNDO, RM1. So, I would suggest that you should go for Mopac 2016. Okay. So, it is for academic it is free, various methods are there. So many different methods for calculating the molecules is there. It is good for, very good for small molecules and enzymes. Okay. So, Mopac, it is available in Windows, Linux, Macintosh. So, if you can get completely downloadable Mopac 2016 claiming that you are an academic, then you can start using, and you can use all these various semi empirical methods, PM6, PM3, AM1, MNDO, RMN and so on. So, it is really nice to have them. Okay. For example, let us look at the Mopac 2016. As I said, the Mopac 2016 is available free for academic and non-profit organizations. So, so I suggest that you all get that and then start using some of the semi empirical methods. Okay, so you see Mopac 2016. You can get a license. Okay, so you have download standalone 32-bit Mopac 216 for Windows. You can get here license from them. Once you get the license, you can run the program and insert the license key. Okay, so as you can see here, it gives you zip. Okay, then we can run, and then we can put the license key inside and so on actually. So, it is not difficult. okay. So, but in order to get a license you need to go okay, to get a license okay. So if you give name of the institution, name, city, state, country, email address for license key. So email address has to match your academic institution, okay, so that they will confirm it is a bona fide academic institution, okay. From bona fide academic institution is required, okay. So you can't give any email ID which does not reflect your institution. So if you do that, you submit to that particular mail, you will get the license key, and once you do that we can download, like I said, we can download, and then okay, we can download the 32-bit version and then incorporate the license key. So it's one of the best semi-empirical methods I can think of. Mopac is a software which can be used for calculating the semi-empirical quantum mechanic features of any molecule. It's a free software, downloadable, and as I had mentioned, it can do PM3 type of calculation, and now currently it does a PM7 type of calculation. So we can download and then we can install that, and then we can get the semi-empirical features of molecules. For example, let's take aspirin. Aspirin, you need it in the .mop file. We can use OpenBabel to convert, as I said, any format to any format. So aspirin, we can download the mol2 or SDF file from zinc, and then we can use OpenBabel to convert. So if you look at the aspirin, this tells you the x, y, z coordinates, okay, tells you the x, y, z coordinates, and then okay, so and then it also tells we can optimize the structure. So basically Mopac can optimize using semi-empirical methods. So you have carbon, carbon, oxygen, carbon, and what are the various x, y, z coordinates of each one of them. So you can see carbon, oxygen, hydrogen, so everything is there. This is called a .mop file. We can give that. Okay, now we can run this using Mopac, and I have it on my desktop. Okay, Mopac. So I just say aspirin Mopac, and then it runs it. Okay, so you get the aspirin out file, and the out file gives you all the information, the semi-empirical information. So it runs a PM7 calculation. Okay, it gives you the symbol, the coordinates as given by us. Okay, then it does in this particular case I think 10 different confirmations. We can give 100 or 200 so that you get the best minimum energy confirmation based on electronic semi-empirical calculation. So as you can go, it gives you a lot of electronic features, okay, electrons and so on. Okay, then it gives you the heat of formation, total energy, electronic energy, core repulsion, all the information, okay, molecular weight, LUMO, okay, ionization potential. So everything that's related to electronic is given using Mopac. Okay, that's the usefulness of having Mopac, because the force field or molecular mechanics calculations cannot be used for getting these type of electronic information. Okay, it gives you final heat of formation, it gives you electronic energy, core repulsion, everything, okay, all related to, and it uses in this particular case PM7 as I mentioned here. So we can give different types of semi-empirical method also for doing the calculation. We can play around with that, and Mopac is very useful for us to run, and we can view the structure of this using a file, using a software called JMOL, which we have. Okay, this is a software called JMOL. So we can look at the structure of the output from Mopac. Okay, so we can look at the structure as you can see here. This is the aspirin which I have done. Okay, we can using the JMOL. Okay. And as you know, JMOL has a lot of features which it can calculate a lot of informations. With whatever data which we have collected from Mopac. Okay, which we have collected from Mopac. That's the advantage of using this particular software. We can do measurements, we can look at distances, we can vibrate, we can do vibration, so many things can be done, surface tools. Okay, so all the spectras we can simulate spectras. Okay, so we can simulate NMR spectras. All these can be done using JMOL. That's the beauty of this software. And you need this software if you want to look at the output from the Mopac. Surface tools, look at the surfaces and so on actually. Okay, then look at this particular resource also. This is also very useful. Say SCBDD. Okay, so what it does is we can input the smile and then we can select which method. So it will create files, output file format based to that method, and then we can go to Mopac, say 2012 or Mopac 2016 and run that. Okay, so basically this particular page helps you to create files. We can input the smile file, very simple. Okay, and then we can select which method you want to follow file for. Okay, and then select the output file and then we can submit, and then you get the output file in that particular format for that method, and then we go to Mopac and run that particular system. So it can be done for MNDO, MNDOD, AM1, PM3, PM6. I said PM6 is PM6 is a reparameterization of the NDDO. Okay, 3 modifications to the approximations made. Besides that, all main group elements or transition metals are parameterized in PM6. So you get all the main group elements and transition metals. Okay. PM7 is a modified version of PM6. A few errors in NDDO theory are improved on that. PM3 uses a Hamiltonian that is very similar to AM1. Okay, Hamiltonian, but the parameterization strategy is different. AM1 was parameterized largely based on a small number of data. PM3 is parameterized with large number of molecular properties. Okay, so PM3 I would use rather than AM1, whereas PM6 is taken reparameterization of the NDDO method. So so Mopac contains all these different methods. As you know, MNDO modified NDO, neglect of diatomic overlap, for the quantum calculation of molecular electronic structures. It is based on the neglect of differential diatomic overlap integral approximation. Okay, so this can do all these calculations. This software is web based software is very useful. We will look at it later in the course of our work, okay, because it calculates many molecular properties. It calculates many molecular properties, large number of properties, or it is called descriptors, molecular descriptors once we give the molecular structure. Okay. So we can sign in or we can use as a public also, and then we can do this type of calculations. We will come to that when we talk about QSIR looking at descriptors and so on actually. Okay, so what does that mean? So we come to the end of the quantum chemical techniques. So quantum chemical techniques basically deals with the ab initio and semi empirical. Ab initio method is very detailed type of calculations. So it can be done only for a few atoms, but not for large set of atoms. Even for doing that you need to use certain approximations like Hartree-Oppenheimer approximations and Hartree-Fock type of approximation. Okay. So whereas semi empirical method parameterizes many of these calculations, it takes in some equations, thereby it simplifies the number of calculations involved. But advantage of this is we can still use it to determine electronic energy, we can use it to determine the nuclear energy, we can use it for finding bond energy required for bond breaking, bond formation, we can look at energies of transition state, ground state and so on actually, which cannot be done with molecular mechanics method. So molecular mechanics methods have limitations, although it is very fast, highly parameterized. The force field methods are highly parameterized, but it cannot do the chemistry related calculations. So you need to go for quantum mechanics methods, and basically these are that. And in semi empirical method Mopac is one of the best packages I would recommend, which is free for academic users. So it can do a lot of semi empirical calculations based on say AM1, PM3, PM6, PM7, okay, neglect of differential NDO type of methods. So as I said, it is free, you can download it, get the license and start using them, and it can give you a lot of information regarding the molecule under study. Okay. So we will continue further on the computer aided drug design in the next class as well. Thank you very much for your time.